Okay, Assalamu alaikum wa rahmatullahi wa barakatuhu. Okay, so today we are going to do a chapter of refraction. Okay, so what is refraction? Any idea? Okay, Yusra?
It is depending of the light rays.
Bas, that's it. End of the story. Why? Come on. Okay, Yusra,
Is traveling from one
sorry?
traveling from one place.
Is this how you answer? Okay, Abdul Wadud, this is not how you define scientific terms. This is just the bending of light. That's it. End of the story. If you ask somebody what is refraction and I give you that answer.
Ma'am, the bending of light is the fraction is called the bending of light when it passes from one medium to another.
Yes. Yes. This is the complete definition. So Yusra, please make sure that you correct this part that you missed. Okay, don't miss this part again. So the bending of light when it passes from one medium into another is called refraction. Okay, and why is that? Why? What is the cause behind this bending? Why couldn't the light just pass through without bending? Yes, Ujala?
Is it because the speed changes as it travels from one medium to another?
Yes. Yes, very good. The speed changes. So, Ujala, are you a new? I think you're attending for the first time. Are you? Oh, she left. Okay. So, yes. So, why does the speed change? Any ideas? Why does the speed of light change when it changes the medium? Any idea? Yes, Yusra. Yes, Yusra.
Miss, I think it's because of the density of material.
Sorry, your voice is breaking because of.
Because of the density of the material.
Okay. Yes. 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 It has to do with the density, but again, can you be a little more detailed? Yes. You know, the reason why I'm asking is because I want you to think. Okay, I want you to think. If I just plainly give you facts and figures, then there would then you know it won't be different from reading a book. I want you to think. So why is it that the speed changes? What is light, by the way? What is light?
It is a source of radiation.
It is the source of radiation, or is it a yes?
A form of radiation.
Yes, it is a type of radiation. It is a form of radiation. Remember, we did electromagnetic spectrum, and visible light was the visible part of the electromagnetic spectrum is light, okay, made up of 7 colors. 7 colors together make white light, right? So, okay, so what did we learn about the electromagnetic radiation? That it can travel through what sort of media? All sorts of media, right? It can travel through all sorts of media, and the speed of light is maximum in which medium? In which?
Air.
Sorry?
Air.
There's a medium in which the speed of light is even faster than in air. What is that? Yes, Sarah?
Vacuum. Vacuum. Vacuum.
Yes, vacuum. Yes, space has vacuum. So why is it fastest in space is because in vacuum. So this tells us that the more the particles there are in the medium, the more the obstacles for light. So light does not like matter in its way. So matter is like an obstacle. It hinders its way. It's like hindrance. The particles or the atoms, they're like hindrance in the way. So more tightly these particles are packed, the harder it is for the light to travel through it. Okay, so it will be easiest for the light to travel through vacuum compared to air, and then it will be easier for the light to travel through air or gases than through liquid, and then it will be easier for the light to travel through liquid than through solid. In fact, through solid it does not, it does not pass through it until and unless it's transparent or translucent. So we learned that there are particles in a medium, the difficult it is for the light to travel. Okay, so difficult meaning that it will be slower. Okay, now whereas with sound wave it's the opposite. Do you appreciate that? Do you know that for a sound it's the other way around? Why? Because sound requires, yes, Abdul Wadud, can you explain why is it the opposite with sound? Yes, Abdul Wadud.
Because it needs particles to travel.
Very good, because it requires particles to travel. Because what is sound? Sound is the vibration of particles. So if there are no particles, what will vibrate and how will sound be produced? Right? So sound is different in this way. In fact, it's just the opposite. So sound will travel the fastest through solids as compared to liquids, and then faster in liquids as compared to gases. And it cannot travel through vacuum at all, because in vacuum there are no particles. So you cannot there are no particles to transmit sound waves. Therefore these astronauts, they claim, I don't know, but they claim that they use radio waves instead to communicate with each other. rather than sound. Okay, so they use other waves. Okay, now radio waves, by the way, radio waves are part of electromagnetic spectrum. Again, they are also part of type of radiation, and therefore they can travel through vacuum. Okay, so let's talk about refraction. So we know that refraction is the bending of light when light travels from one medium to another due to change in speed. Due to change in speed. Now, how does that happen? So I would like to use an analogy which is also used in many books. So I'm going to use that analogy to show you that bending of light when it travels from one medium to another, and which is, okay, so can I have the camera here? How should I show this? Okay, let me use this other book. For example, let's say, for example, this is the road. Okay, for example, this is the road, so car can easily travel, right? And let's suppose, just use your imagination, that this is sand. You know, this other book that I'm using, this is sand. Okay, now if this car approaches this sand at a perpendicular, like for example, if both the tires touch this sand at the same time, when both the tires or both the wheels of the car touch the sand at the same time, then of course on the sand the speed of the car will decrease, but both the wheels will slow down exactly at the same time and by the same amount, right? Both the wheels will slow down by the same amount and exactly at the same time. So therefore the car will still move in the same direction, but it will slow down, but in the same direction. Okay, so that's all that will happen to it. But if the car reaches this interface, I will call this boundary or interface between the sand and the road at an angle. So if you can show this way, so you can see that this wheel is touching the sand, but the other wheel hasn't touched the sand as yet. Can you see? One wheel has touched the sand before the other one. So therefore, this wheel will slow down before this other wheel. And so this wheel will travel at a slower speed, whereas this, can you please hold the camera? So hold it this way. So this wheel will slow down before this other wheel, and this other wheel will keep traveling at the same speed. So as a result, this car will turn. Why? Because this slowed down before this one. So while it was moving slower, this was moving at the same speed, and so turning will take place. Okay, so this will slow down and the other will keep moving at the same speed, because why? Because this wheel is still on the road. Therefore, the speed of this wheel has not changed, has not been affected. So this will keep traveling at the same speed. This will result in this difference in speed. So this wheel is slower, this wheel is at the same speed. So because of the difference in the two speeds, the car will turn. So the light waves don't exactly behave this way, but this is a good analogy to understand the bending of light. Okay, so remember, this is only an analogy. Okay, remember, this is only an analogy. Light does not actually behave like a car, but this is good for understanding. Okay, okay. So now, if the car is moving from the sand, is coming from the sand onto the road, same phenomenon will take place, but in the reverse, in a reverse way. Why? Because now when this wheel, again, this wheel is touching the road first, and so it will get faster before this wheel, whereas this other wheel is still in the sand, so it's still moving slower. Okay, so no, keep it this way, keep it the same way. Okay, so this will get faster, this will get faster, and this will still be slower. Okay, so again, they will be turning. Okay, there will still be turning. Okay, so now you understand why there is bending of light when the light travels from one medium to another due to difference in their speeds. Okay, yes, Abdul Wadud, I saw your hand raised. Do you have a question to ask?
Yes, I had a question, but I forgot.
You forgot. Okay, it's okay. You might remember again. Okay. Okay, so now let's use this concept of bending of light on a prism. Now, there are two shapes of prism that you usually will come across
Assalamualaikum, ma'am.
in exams. Okay, keep it here. Keep the camera here. So there are two shapes of prisms that you will come across in exams and you will deal with. Uh, so one shape is in which the opposite sides are parallel to each other. This is a rectangular block or a rectangular, you can call it a rectangular prism. And then you have this triangular prism, but it can be any shape. But the thing is that the two sides are not parallel to each other. Okay. Now, I hope that you already know the concept of incident ray, normal.
Yes, miss.
Yes. Okay. So let's try to understand refraction in terms of light using this rectangular prism. First rectangular prism and then triangular prism. Okay, so this is the boundary. This is the boundary between glass. We have glass here and then we have air here. Okay, so air is a gas and glass is a solid. Okay, and so glass is optically dense. Okay, remember that when we talk about density here, you know, when you said, you know, because the substance is denser and therefore the light is slowing down.
Ma'am,
Yeah, wait,
ma'am, is
wait,
this
wait.
refraction
No,
related?
Zores, please do not interrupt me. Okay, you will raise your hand only when I will allow you. Okay, so glass. So when we say density, we mean we mean optical density. Okay, optical density. Now, what do I mean by optical density? That's a difficult concept to understand, but just understand that optical density means that it is hard enough to slow the light down. Okay, so light slows down when it enters into an optical denser substance. Okay, so glass is optically denser than air. Hold it like this. Okay, so glass is optically denser than air, meaning that it slows down the light. So yeah, one way of understanding is that, you know, it is solid and so it has a lot of particles in it, whereas in air the molecules are farther away and so a lot of space is empty in air. Okay, so it's easier for the air to easier for the light to travel through air. Okay, so I will choose any point on this surface. This is the boundary between the glass and the air. Okay, and so I will draw my incident ray. I will draw an incident ray. Okay, this is the incident meaning falling. Incident meaning, for if I am using any term that you don't understand, please let me know. So this is the incident ray.
Ma'am, I don't understand this. What is this? What is this point you made? This incident, this point you made when you say
Yeah,
air.
Doris, the thing is that I am teaching this topic on the request of grade 9 students. You know, my own planning was to follow the book, and it was according to that planning that I allowed grade 6 students to join. But because this is coming in their exam, maybe this is included in their exam, so I am, you know, going out of my way to do this. So maybe you won't understand this since you are in grade 6. Okay, so if it's totally up to you to stay in the class. Okay, so this is an incident ray. Okay, and now this is perpendicular. This is
Ma'am,
perpendicular.
what's an incident ray?
I just told you it's a ray which is falling on a surface. Okay, it is a ray which is falling on a surface, so that is called an incident ray. Okay, now what is a normal? Normal is perpendicular to the boundary between the two media. Okay, normal is the boundary, is perpendicular to the boundary between the two media. So we have glass, we have air, and the boundary between them is this surface. We also call the boundary surface, and the line which is perpendicular to that surface or boundary is called the normal. Okay, now if there was no refraction, or if there was no hindrance to the path of light, the light would have just simply continued its path, right? In this way. But because
Yes.
of this glass, because of this optical denser medium, it got hindered. Its speed slowed down. It got hindered. And just as I showed you that analogy, so now this wheel will get slower and this will get faster. This will get faster. And so the car will move this way. The ray will move this way. So remember, whenever light travels from an optically less dense medium to an optically denser medium, it slows down, first of all, and that slowing causes it to bend towards the normal. It bends towards the normal. Now, how do I know that it has bent towards the normal? See, initially, if it had continued unhindered, it would have gone this way. But can you see that it has deviated? And this is the normal, right? This was the normal. It deviated towards the normal. Okay, how would it have deviated away from the normal? Well, if for example, this was optically denser and this was less dense, and it was deviating away from the normal, then it would have deviated this way, away from the normal, from its unhindered path,
And
away
then
from
what
the
is
normal. Please do
optically?
not interrupt me. Zores, I would suggest that you leave, okay, because you will not understand. So, if from its unhindered path, it will be deviated away from the normal. Okay, why am I stressing so much on this? Is because many students are asked to draw this diagram and they get confused. Okay, so okay, now what will happen next? This will continue. Okay, this path will continue. Okay, and now again it is changing its medium. Okay, now from the glass to the air, again there is change in medium, so again change in speed. But this time, again, I will draw a normal. I will draw a normal to see how it will bend. If it was unhindered, I will draw its unhindered part just for my convenience. So if this was its unhindered path, this is the normal. I will write normal, okay? And now it is entering into an optically less dense medium, so it will move away from the normal, So it will be like this. Sorry, I got a little, yeah, you should use a protractor to make these drawings.
Stay the same.
Okay, yeah, normal is always perpendicular to the boundary. Normal, always, no matter what. Okay, so now can you please hold the camera this way so that I can show them? So this is the incident ray. This is the refracted ray. Okay, and this is called the emergent ray. Emergent because it came out. Emergent ray. Okay, so now if you see, this emergent ray is parallel. This emergent ray is parallel to the incident ray. Remember, when the two sides of the prism are parallel, when the two surfaces of the prism are parallel, can you please keep the camera? Yeah. Okay. When the two surfaces of the prism are parallel, the incident and emergent ray are also parallel. My lines are not exactly parallel because I drew these lines without the protractor. But if you draw it with the protractor, you will see that the incident ray is exactly parallel to the emergent ray, provided the two surfaces of the prism are also parallel. The two surfaces meaning which two surfaces? The surface, the surface on which the ray is falling, and the surface from which the ray is exiting. Understand? These two surfaces should be parallel to each other. If they are parallel, then the incident ray will also be parallel to the emergent ray. Okay, so this is refraction through a prism with the two surfaces parallel. Yes, now I will take questions. Yes, Abdul Wadud? Abdul Wadud, yes, you can ask your question now.
Yes, I want to ask that can a incident ray be like refracted at 90 degree?
Yeah, first you understand this. Okay, we will move on to that later. Okay, that 90-degree, yes, it can be. Yes, 90-degree refraction can be. Okay, that will be dealt with in the next chapter. Okay, yes, Yusra?
Miss, I have two questions. Miss, like, can you tell like how we know whether the ray will be bending towards the normal or away from the normal?
Yeah, so you have to look at which one is denser, which one is less dense. Okay, so in denser, the speed will slow down. If the speed is slowing down, imagine it this way, you know, the light is trying to come, somebody is stopping it, and when it is stopping, it got bent. Think of it, you know, just for remembering, this is not exactly how it happens, but you know, just for remembering that. So when it is slowed down, it moves towards the normal. Okay, and when it is allowed, it has freedom to move, again the same speed, then it moves away from the normal. Khulla hoke chalta hai. You know, whatever works for you, but just to remember. Okay, Yusra, so you have to look at the optical, you have to look at which medium is denser. You have to look at which medium is it slowing down. If it is slowing down in the medium where it is slow, where the speed is slow, the ray should be closer to the normal. And the medium in which the speed is high, the ray should be away from the normal. Okay? Yes, Muhammad?
Ma'am, I wanted to ask that how can we know that the exact angle of the light bending
Well, you will be given
with the
angles.
protector?
Yeah, you will be given angles. Yes, and sometimes if they ask you to use a protractor, then you may. Otherwise, we will do the calculations that will help us. Okay. Okay.
Okay.
Okay. So this was simple refraction. I was just explaining you simple refraction through a prism which has two surfaces parallel to each other. By the way, this is the first question at the end of this chapter. They have shown you a prism with parallel sides, and they are asking you to draw the path of the incident ray. So this is how you are going to draw. Okay, here I got a little wrong here, but otherwise this is how you will draw. Yes, Yusra? Yes, Yusra?
Miss, can you please the parallel phenomenon again? I don't understand that.
Beta, did you understand refraction? Did you understand how this rays got refracted here and then back here? Did you understand that? Did you understand?
Yes.
Yeah, so you understood that the light got refracted at first time here, and then it refracted back to its initial direction back again. So at the end, you have a parallel light rays. So meaning the direction of the emergent ray is the same as the direction of the incident ray, but only thing that it has been displaced sideways. It has only been displaced sideways, but otherwise the emergent ray direction is exactly the same as the incident ray. Okay. Yes, so Sidra wants to ask a question. Yes.
My question is it ever that like it doesn't bend? It's like
Yes.
straight.
Yes. Okay. So that's a good question. So if the light, so I just told you that analogy that if the car's wheels are touching the other medium, both the wheels touch the other medium exactly at the same time, the speed will slow, but the car will not bend. Why? Because both the wheels got slowed down at exactly the same point in time. So similarly, when the light falls exactly perpendicular meaning exactly on the normal, okay, so that means the angle of incidence is 0. When the, because what is the angle of incidence? What is the definition of the angle of incidence? Can somebody recap?
A ray that enters the
No, angle of incidence. Angle of incidence. Definition of angle of
It is
incidence. Yes,
it is the
Anna?
ray falling on a surface.
Beta, angle of incidence.
angle that's
Angle of incidence is an angle between the normal and the incident ray.
Very good. Yes. So angle of incidence is the angle between the incident ray and the normal. So when the incident ray is exactly at normal, the angle is 0. So when the angle of incidence is 0, that's when the light does not refract. Okay, and you can remember it with this car analogy. Okay, now let's move on to refraction through a prism that has surfaces which are not perpendicular to each other.
then that means incident rays will
No.
also like
Yeah. So again, the same phenomenon, same everything, but the thing is that the emergent ray will not be parallel to the incident ray. Why? Because again, the light is passing through refraction twice. Once when it enters, the second time when it exits. And at both times, the refraction is through an angle that further, I mean, the second refraction further bends it rather than bringing it back. Here, the second refraction brings the light ray back to the initial direction. But in such a prism where the two sides are not parallel, the emergent ray is not brought back, in fact is bent even further. So the emergent ray is quite bent compared to the incident ray.
it's again bent away or close.
Yes, but the laws of refraction still hold true no matter what the surfaces are of the prism, meaning that when the light enters an optically denser medium, it will bend towards the normal. And when it enters an optically less dense medium, that is where the speed of light is faster, it will bend away from the normal. So let's do this, okay? Yes, Naba? Yes?
Yes, but I'm sorry to interrupt. I want to say Assalamu alaikum. I just joined this class through an ad.
Okay. So do you have a question?
No, not right now.
Okay. Are you from Pisces?
Yes, I'm from Pisces.
Oh, okay. So, okay. So this is a triangular prism. Okay. So let me explain this now. This is a surface. So again, we have air here and this is glass. Okay. So glass is optically more dense. So we expect the light to slow down when it enters glass. Okay. And so this is the surface, or this is the boundary. Okay. And this is the normal, meaning perpendicular to the surface. This line is perpendicular to the surface. Which surface? The surface of the prism. Now, this is the incident ray. This is the incident ray, okay? And so this must be the angle of incidence. Angle of incidence is the angle between the incident ray and the normal. Okay, now I will extend this normal for my convenience. Okay, now if this ray was unhindered, it would have continued this pathway, but because now it is hindered by glass, and the speed is slower in glass, it will move towards the normal. Remember, this was the normal. So it will bend towards the normal, okay? Now it will continue, and again, it will refract on the opposite side, again, when it is exiting the glass and entering the air, okay? Now this time, the surface is this. And so the normal is this. Sorry. Okay, can you see? Sidra, can you please camera को इस तरह से? ये हाँ ऐसे. Okay, so this is the normal. Okay, remember, always make your normal where the ray is crossing the surface. Okay, make your normal where the ray is crossing the surface. Okay, so if this is the normal, okay, now if it was unhindered, again, it would have continued this way, but because now it is in a different medium where it can travel fast, it will move away from the normal. This was normal, so it will move away from the normal. Okay, so can you see it had bent it even more? Okay. Okay, now, for example, this is white light. Okay, now I am explaining you dispersion. Yeah, because you know we are dealing with this, so let's do dispersion at the same time. Now, if this is white light, you know, is made up of 7 colors. Now, what's the difference between the 7 colors? Can anybody tell me?
Yes.
What? Yes, Zainab?
Their wavelength.
Wavelength?
The 7 colors
Yes, Abdul.
are having different frequencies.
Yes, yes, they differ in their frequencies and wavelength. Okay, and that affects the way they and that affects the amount to which they bend. Okay, so if you have, these are the 7 colors, right? Vib Goyer is a mnemonic to remember them. Okay, so frequency increases this way towards the violet. Okay, red, orange, yellow, green, blue, indigo, violet. We all know this, right? These are the rainbow colors. And so the frequency,
Yes, ma'am.
yes, so the frequency increases towards violet. And so violet has the least frequency and longest wavelength. So, sorry, violet has the most frequency, okay, most frequency and the shortest wavelength, okay? So more the frequency, more the bending. Remember this, more the frequency, more the bending, okay? More the frequency, more it will slow down. And because it will slow down more, it will bend more. Remember, more slowing down, more bending towards the normal, okay? So if, for example, we have red and we have blue, I just took 2 colors. Okay, I just took 2 colors for it. Okay, red and blue. So this is red, this is blue. Okay, so red, you can see, has the least frequency. This has least frequency and this has most frequency. So bigger, and can you see blue is here? So blue has more frequency than red. So blue will bend more, though they were incident simultaneously, like they fell on the surface at the same angle, in the same direction. But blue bent more. Why? Because its frequency was greater, and so it bent more. Because the red had less frequency, it bent less. And because of the difference in bending, they have separated. First, they were together in the same light. But because blue bent more than the red, now they are separate. Now, again, I mean, this way they will continue through the prism until they reach the other surface. The other surface. And now, again, they are back into the air. Now, because in the air they can travel faster, they will move away. Now, for example, red. Let's concentrate on red. Okay. It would have continued this way, but because now its speed is faster, and this is the normal. By the way, this is the normal. Okay, because normal has to be perpendicular to the surface. So it will bend away from the normal. Can you zoom in? Can you please zoom in? No. Okay. So it is moving away from the normal. Okay. And then blue again did the same thing. Okay. Now this blue would have continued this way. Sorry. Let me use the blue marker. So blue would have continued this way. And then again, this is the normal for blue. Remember, always draw normal where the ray is crossing the surface.
But they don't end up again.
So, okay. Yeah, they will not end up together. No.
But then
No.
how come they were together in one line at the start?
Okay, wait. So now this was the normal. This is the normal again. So now blue moved away from the normal. Okay. So now this is red. This is red. And this is blue. Okay. And if this is the screen, you will see the colors separated on the screen. You will see the 7 colors separated on the screen. So where will you see violet? Violet will be somewhere here. Indigo will be here. And they will fall on the screen exactly the same sequence, Wib Goyer. They will fall at the same sequence, Wib Goyer. Okay. Okay, so this is dispersion of light. Why is it called dispersion of light? Because it disperses or breaks the white light down into its 7 component colors. Yes, Abdul Wadud. Yes, Abdul Wadud. Okay, Zainab.
Miss, before doing dispersion, like the incident ray was splitting into two, but why was it splitting into two? Before dispersion, we did that incident ray was falling on the prism.
I didn't understand your question. See, they were together initially, okay, but because they bent to different extents, okay, the higher frequency bent more and the lower frequencies bent less. Okay, so they ended up spreading out. And on the second surface, they refracted even more. They got bent even more. So at the end, you will see all the 7 colors separated and split out falling on the screen.
Miss, I'm saying before dispersion, like the simple drawing you drew over there, the incident ray, it was splitting into two.
No, it's not splitting into 2. It's a single one ray. That's it. This is normal.
In the prism, it is splitting into two. Before dispersion, you
Oh,
drew the
inside
diagram.
the, oh,
Yes.
see, all the 7 colors are splitting here. But I only showed red and blue because, you know, otherwise this diagram would be a mess. But
Okay, Miss, got it.
yes, okay. There are many YouTube videos on this. You know, refraction through prism, dispersion through prism. You can search and you can watch them, okay, and you will see. And there are diagrams and pictures.
Okay.
I'm so sorry, because of lack of time, I could not get any video for you guys, or I would have done that. But you know, because
It's okay, Miss.
yes, but all the 7 colors, you will see all the 7 colors within the prism as well as outside. Is there a picture?
And Miss, what about the frequency of green color?
Okay.
Like and would it be having the shortest wavelength or the longest wavelength, the green color,
See,
as
this
it is in the middle?
so see, this is where the green color is. Can you see where the G is?
Yes.
So G has a greater frequency than blue. It has greater frequency than blue. So that means it would bend even more. So green would be somewhere here. Green would be somewhere here. Okay, it will bend even more. Okay. Okay.
Miss, shouldn't the frequency of the green be lesser than blue?
Yes,
Because
ma'am.
of the
Oh, yes. Okay, sorry.
Yes, ma'am, it will be lesser.
Yes. Okay. Yeah. Okay. So you will see green here. I'm sorry. Yeah. So that was a mistake. So yeah, green frequency is less, and so you will see green right next to blue, but on the other side.
okay, Miss, so its wavelength would be shorter than blue or bigger than blue,
Show me.
greater than blue.
Show this. I got this picture. I don't know if it will help you. This is how it looks, but you can Google search and you will see beautiful diagrams. Okay, but can you see violet, indigo, blue, green, yellow, orange, and red? Okay, same
Yes, Miss.
sequence. Okay, so splitting takes place within the prism, But in this photo, they could not capture that. But yes. Okay.
Okay, miss.
Yeah. Okay. What was the question that you just asked before this?
The question I just asked was that green color would have the longest, I mean the shorter wavelength or the greater wavelength than blue? Would it be greater wavelength or shorter?
Okay, so a frequency is increasing this way, right? So the wavelength would increase, okay, higher frequency, shorter wavelength. So wavelength will increase this way. They are increasing in opposite directions.
Okay, miss. Got it.
Yes. Because velocity is the product of frequency and wavelength. And so when the light enters another medium, the velocity, for example, if the velocity decreases, frequency stays the same.
Yes.
Frequency stays the same, but it is the wavelength that changes accordingly. Okay, so but don't
Okay,
get
miss.
confused. Yeah, don't get confused. Okay, Sidra, can you now hold this for me? Yeah, okay, so okay, I got this. Oh. Yeah, look at this. So yeah, can you see the splitting took place within the prism? Oh my God.
Yes, miss.
Yeah, okay. Yes, Sarah.
Miss, I wanted to ask, like, sometimes when you look at the CD, right, the light is reflecting, reflecting. There are different colors.
Yes, yes.
Why is
Yeah,
that?
yeah, that is also due to refraction, I think.
But
Yes.
the light is not entering, right? The other side, it's like like opaque.
Okay, I don't know the exact reason, but that's a very interesting question. But there might be some plastic coat on it that might be refracting. Yeah, this is what my understanding is, that you know, sometimes on the CD surface you see these 7 colors when the light is reflected. Yeah, because I think there is some coating, some plastic coating on it, which causes that refraction. Yeah, you can also contribute.
I know, but what I understand is that even the surface or the CD, although the CD is compact, of course, the light cannot pass through the CD, but the surface is refracting, is shining. When the light falls on it, it's still refracting the light. The light, you could see, that's why you see the colors. Somehow the reflection is different, and there's how you can see different colors. Even in water droplets, sometimes even in case of soap, froth, you might see the same phenomena. So it's not necessarily that the light will pass through the object. If it is refracting, because that area is, you could say, shiny, and this is built for this purpose, you know, that's why it's refracting light. So there's one of the reasons that you might see colors, even not necessarily all 7 colors, but depending on the material, you might see this phenomena.
Okay. Did you understand, Sarah?
Yes, miss.
Yeah, okay, okay. Jazakallah khairan. Okay. Okay, now in your book, then they have this practical work. They have this practical work.
Yes, miss.
Yes. So let's just recap it. This is easy. They are showing the same phenomenon practically. Okay, this might be asked in ATP, in your ATP. Okay, so this is the light source, but because they want the light to be in the form of a single ray, okay, they are using the single slit, which is allowing only a thin beam or ray of light to enter this rectangular prism or block. Can you see now? This is a rectangular prism, so the two surfaces are parallel to each other. Okay, and this prism is placed on a white sheet of paper. Okay, now understand that this incident ray, normal, and then the refracted ray and the emergent ray all will be lying on the same plane. They will all be lying on the same plane. So with the help of a pencil, we can trace the pathway of the beam. We can trace the pathway of the beam. We can mark the normal using a protractor and a ruler. And we can also follow the path of the emergent ray. We can trace with the help of a pencil the path of the emergent ray. And then Also, we can draw the surfaces. Okay, and then we can join, and we can, with the help of our knowledge of how refraction takes place, we can follow the refracted ray as well. But of course, for that you will have to remove the block and then join the incident ray with the emergent ray. So that will be your refracted ray. Okay, and you will also point with the pencil the point from where you see the emergent ray coming out. Okay, so okay, let's read this. Okay, so shine a ray of light at an angle onto a glass block. Okay, as in figure 29.2, draw the outline. Okay, mark the position. Okay, we have done all of this. Remove the block and draw the normals on the paper. Okay, let's do these questions. What two things happen to the light falling on AB? What two things are happening to the light falling on AB? Yes, Abdul Wadud?
It
What two things
Ma'am,
are?
it
Yes?
is refracting.
Sorry?
Refracting, it's refracting.
Okay. So you will say that the direction is changing?
Yes.
And
it
And
bends towards the normal.
yeah, so this is what he said. He said change in direction. So okay, bend towards the normal. And okay, Muhammad.
Ma'am, they are refracting towards normal and slowing down.
And hence?
And slowing down.
Yes. Yes. So these are the two things. Change in direction, change in speed. Okay, change in direction, change in speed. Okay. And in fact, slowing down of speed, if you want to be specific. Okay, when the ray enters the glass at AB, is it bent towards or away from the part of the normal in the block? Away or towards? Zainab?
Towards the normal when it enters the glass block
Why?
because the speed of the ray it decreases.
Right, right. How is it bent at CD? So now you have to tell me away from normal or towards the normal at CD. Sidra? At CD, does the light bend away from the normal or towards the normal?
Away.
Very good job. Okay, what can you say about the direction of the ray falling on AB and the direction of the ray leaving CD? Yes, Yusra? Yes. Okay, Sidra.
On AB, the ray is moving towards the normal, and
No. What can you say about the direction of the ray falling on AB and the direction of the ray leaving CD? Meaning, what can you say about the direction of the incident ray and the emergent ray? Yes,
Ma'am, can I?
Yes, okay, Muhammad. Yes.
They are parallel to each other.
Very good. Very good. They are parallel to each other. What happens if the ray hits AB at right angles? Yes, Zainab.
It will continue as a straight line because it is along the normal. It will become along the normal.
It will become what?
along the normal.
Along the normal. Okay, yes. So it will be, it will not bend. Okay, it will not bend.
Yes, it will be
Very
straight.
Okay, so that means you understand this concept. Okay, let's move on. Okay, my understanding is that real and apparent depth are not included in the IGCSE curriculum. So let's say
It is included, miss.
it is included? I don't think so.
Yes.
Okay. Okay.
Yes, we did it in the class.
Yes, we did it in the class.
Okay, then explain me.
So when the rays of the light falls on water, as water is more dense, the rays will refract. It will bend towards the normal.
Okay.
And then as the image, it is, miss, can you move the diagram a little bit on the?
Yes. Okay.
Yeah. So these rays, it will bend over here because it is more dense. The water is more dense, so the speed would decrease and the rays would bend towards the normal. But for the apparent, yes,
the normal.
The normal, because in water it is more dense than air, so it will move towards the normal. The
The ray, is the ray entering the water?
Oh, it is. No, it's going. So let me do it opposite. So the ray leaving the water is more dense than the air is less dense. So the object, the rays going from the water, they would be towards the normal. But when it passes through the boundary, it would be away from the normal as air is less dense. The speed would increase, but our eyes would see the point I as the rays for the eyes, like the light from the, you can say, the object, the apparent that would be less than the object.
Yes, very good. You've done a good job. Yes, Zainab. Okay. So, okay, let me explain this real quick. Sidra, can you please hold the camera for, properly? Thank you very much. Okay. So I hope you can see. Okay. So, okay, let me make this. Okay, these are the incident rays. Okay, these are the incident rays, and for example, the point O is what we are trying to see. Okay, and so now here it is, the medium is changing. Okay, so now it can travel faster in the air. So if, for example, this is the normal. Okay, this is the normal. Okay, so it would have continued this way, but because now it is in an optically less dense medium, it will move away from the normal. This is the normal. So now it has moved away from the normal. Can you see? Yeah, please. Thank you.
Yes, miss.
Yes, okay. So this also has moved away from the normal, okay, this way. Okay, so now what our eyes perceive is these, if you extend these emergent rays, if you extend these emergent rays, they will coincide at point I. Okay, so we will see an image of point O at point I. So you can see that from the top, if we look at an angle, if we look perpendicularly, this won't happen. But if we look at an angle, then it would appear as if the water is shallow. It will appear shallower than it really is. Okay. But if your eyes are perpendicular, then of course the incident ray will be entering your eyes perpendicularly, and there will be no bending. Okay, so this is all there is in real and apparent depth. Okay, let's move on to refractive index. Now, refractive index is a ratio. We can look at it two ways. One is the ratio of the speed of light in vacuum over the speed of light in the medium that you are considering. So refractive index is a ratio of speed of light in vacuum over the speed of light in any medium that you are talking about. Okay. Okay. Now, because practically speaking, we cannot have vacuum. It is difficult to have vacuum, practically speaking. Therefore, we, instead of vacuum, we consider air. Okay, so same thing. The difference is not that much. So speed of light in air over the speed of light in the medium. We can also, this happens to be equal to the sine of the angle of incidence over the sine of angle of refraction. Okay, so these are the two ways of looking at the refractive index. Okay, now what is sine? Sine is, it's a function in scientific, it's a scientific function in calculators, and I don't know the details of this. Okay, okay, so
Okay,
yes, okay, so more the light will slow down, what would happen? What would happen to the angle of refraction? See, if this is the incident ray, okay, and this is the normal, okay, the more it will slow down, the smaller the angle of refraction would be, right? The more it will bend, the smaller the angle of refraction would be, right? So this would be small. If this is small, this will rise because they are inversely proportional. Okay, so more the bending, more slowing, more the refractive index. Okay, and more the slowing, this will decrease as well. Speed of light in that medium will decrease because more slowing. So again, the refractive index will increase. Remember, more slowing, more refractive index. So more optically denser, more slowing, higher the refractive index. Okay, and because I think diamond is hardest, I think diamond has one of the highest refractive index, but I'm not sure about that. Okay. Okay, so with this, I think I have covered this chapter, and we can do the end of chapter questions maybe in the next class. Oh, okay. Okay, so Dr.
Regarding the
Bukhari wants
CD,
to say something.
yeah. I think somebody asked about the CD, right? How we see colors, different colors on the surface of the CD. So think about this. This is CD. So here, this is a plastic part which is coated. So
Yes.
what the exact explanation they have given and various literature.
So I think it has plastic coating, which is, you know, allowing the light to
reflection. No, they say there are small cracks, there are small
Fact.
scratches, and when the light hits the edges of those small scratches, it's reflecting light at different angles. And that's why you would see in a rainbow color at the surface of the CD.
Oh, you mean, okay, so you mean to say that different frequencies are getting reflected
Correct,
in
yeah.
different way?
Yes.
I mean in different angles.
Different angles,
Okay.
yeah. Because there are small scratches and there are small cracks also, because this is a metal coating, right? So this metal coating, when the light falls on the edges of those scratches or those edges, that will reflect light.
Okay, okay, okay. Thank you, Jazakallah khairan. Okay, is there any
Thank
question?
you.
Yes, Muhammad?
No, miss, no question.
Okay, okay. So I couldn't do the end of chapter questions due to lack of time. So, but I did this. I have done question number 1. This is the same that I drew for you. And then this also is the same that I drew, you know, the red and blue refraction that I showed you. This is that question. So I have done
Yes,
question
ma'am.
number 1 and 5, but yes, 2, 3, 4, 6, and 7, I did not do. Okay, the inshallah I'll do in the next class. Okay.
Miss,
Yes.
miss, can you please add my number in the group? Previously, I took your number, but I couldn't get the WhatsApp message.
Okay.
Miss, can
Direct message. So can you just write my number?
Okay, you want to give it here in the class?
Yes.
Okay, let me stop the recording.